to all of you. We at CPQD would like to thank you for joining us at this workshop on standards for IoT, as we look forward to learning more about ongoing work in Europe and discussing how we can advance work in Brazil as well. At this time, we would like to invite our CPQD Director of Innovation, Paulo Curado, to come forward and begin our workshop.
Good morning for everyone. It's an honor to receive you here in CPQD. On behalf of Executive Board of CPQD, I'd like to welcome all of you in CPQD for this important workshop. Especially, I'd like to thank to ETSI, to the confidence and trust from CPQD to perform this work here in this workshop. And I'd like to thank you for the government, local and federal government for the presence here to open our workshop, and the companies and the certification organisms. It's an honor to receive this workshop because the commitment from CPQD start from 4 directions. We have 4 directions from CPQD. The first of all, this is strengthen and grow the CPQD, and the leadership in IoT. And here we are talking about IoT and his challenge in the next period. With the convergence of real world and virtual world, physical and virtual world, we have the challenge for some areas. CPQD works on connectivity and artificial intelligence. Oh, we don't have the laser here. No problem. Oh, here is working, and we have 3 other themes, areas: smart city, agribusiness, and manufacturing. And for ETSI, for standardization, is a challenge too, because in the contribute from the IoT world, especially in Brazil. The standardization is responsible for interoperability and the governance of all the systems that you have. For this reason, this workshop is very important to connect the ecosystems in Brazil and Europe to discuss about everything that happens in IoT world. Thank you so much for Xavier. Special thank for Xavier for his presence here, for all of you in CPQD, and I hope that you have a very good day to make your connections. Thank you very much.
Thank you, Curado. Now we are going to listen to Xavier Piednoir. Xavier is Head of External Relations from ETSI, European Telecommunications Standard Institute, who will make his initial remarks.
Thank you, Claudia, and thank you everybody for being here. Thanks a lot to CPQD for hosting us today. I think it is a very good collaboration we have going on with CPQD, working on a study for us, and this is only, I think, the beginning of further collaboration and further events together. We are here with my colleagues from ETSI, from CNRS, a big research entity in Europe, and Sensinov, one of the leading players in the world of IoT in France and beyond. And I will say a few words about ETSI, just to set the stage. I know some of you are familiar with what ETSI is. Actually, CPQD has been a member of ETSI in the past. So it's not really unknown territory, I would say. ETSI is a standardization body recognized in Europe as a formal European organization to develop European standards for telecommunications. It is European, but it has a reach which is way beyond the European borders because our specifications have been adopted in many other regions. Actually, ETSI was born to host the work on the GSM technology, and then it partnered with others to build a 3G, 4G, and now working on 5G. And this is one of the leading achievements of ETSI with other wireless technologies. We work on many of the topics that were also presented on the slide just before. AI, connectivity, advanced management of networks, IoT, smart cities, security with a focus on quantum cryptography. We have global partnership projects. 3GPP is probably the one which is most known, and that's where we host the work on 5G. 1M2M is the one working on IoT. You will know more about this today. And we are a body where there is direct participation from the industry. We also have an entity which has the same acronym as your neighbors from CTI. For us, it's the Center for Testing and Interoperability, which is a key also element in what we deliver. We want to make sure that what we deliver ensures interoperability. So you have some facts to the right. I know we are starting late, so I won't eat more time, but it is a very exciting prospect to have the event today. Thank you.
Thanks, Xavier. Well, considering the importance of the National Plan for Internet of Things in Brazil, we are now going to listen to Guilherme Correa, from Ministério da Ciência, Tecnologia, Inovações e Comunicações, MCTIC, who is the coordinator of Technology, Innovation, and IoT. Please, Guilherme.
So, good morning. My name is Guilherme Correa. I'm the Innovation and IoT Coordinator in the Ministry of Science, Technology, Innovations, and Communications. This is not my first time here in this stage, but it's the first time in English. So, sometimes I will speak, sometimes I will read, okay? And first, I would like to thank CPQD for this invitation and for the opportunity to be presenting once more the Brazilian IoT National Plan, okay? Well, here we have a quick view of the structure of the Ministry of Science, Technology, Innovations, and Communications. We have no focus. Okay. The pointer is not. Okay, no problem. We have the minister, and below we have 7 secretariats giving support to the minister. And here is where I work in the Entrepreneurship and Innovation Secretariat, where we work with the IoT National Plan, okay? Well, this, just for information, this is how our minister planned the work of the ministry. We use the TRL, Technology Readiness Level, as a reference, and the secretariats of the ministry work in all levels of the scale. So we have here above 3 secretariats. SEMPI is our secretariat. We have below the infrastructure secretariats, broadcasting and telecommunication, and the planning secretariats, okay? So this is the idea. All the secretariats working in all levels of the TRL scale. Well, so let's talk about IoT. This slide shows to you the investment perspectives from 2019 to 2022. And as you can see, IoT is in first place among all of these digital transformation technologies. IoT is the first by far. So the perspectives in IoT are very, very big. And now, let me show you this timeline. Our history with IoT in Brazil starts in 2012 with the reduction of Fistel. Okay, it's a tax that goes into the devices, the telecommunication devices. In 2014, the Decree 8234 determines the creation of the IoT chamber, which monitors the impact of the Fistel reduction. And in the same year, 2014, if we observe the hype cycle of Gartner, IoT was in the peak of the expense, the expectative. And in the same year, we created the chamber we call M2M chamber, okay? 2015, we had the first meetings, and we started the engagement process inside the government. In 2016, we had a complicated year. We had the impeachment of our president, Dilma, but still we made some work. We changed the name and the management of the IoT chamber. In 2017, we had the IoT study in partnership with BNDES, our development social bank. Moving on, in 2018, we started the action plan. And finally, this year, we had the publication of the decree. in last June, and now we are working with the creation of the 4.0 chambers, okay? In the 4 environments of the IoT plan. I will talk about this in a few minutes. This slide shows a picture of a meeting in IoT chamber. Probably this picture was in 2015 or 2016. Inside the IoT chamber, we have more than 70 institutions. And since 2014, the IoT chamber aligns and centralizes all the initiatives inside the federal government. Well, this slide is important because this slide summarizes an important moment for us in our Brazilian IoT history. This slide shows the IoT study. The IoT study for us was a milestone. I think we can divide the history of IoT in Brazil in 2 points: before the IoT study and after the IoT study. This study was made together by MCTIC, the Ministry of Science and Technology, by BNDES, and by the consortium which is formed by McKinsey, CPQD, and Pereira Neto and Macedo advogados, lawyers. In this study, we produced more than 20 documents, some of them with more than 200 pages. We had documents with international benchmarks, documents about Brazil, about our market, exploring the demand side and the supply side of our market. We have documents about the environments. We studied initially 10 environments. And also we have documents about the aspiration which Brazil should have about IoT. All these documents are public. They are in our website, in MCTIC website, and also BNDES website. But unfortunately, these documents are all in Portuguese, okay? They are not in English. And one of the main results of this big effort was the prioritization of the environments. And here we can show you the 4 prioritized environments: smart cities, health, rural, and industries. These environments is where the impact of IoT would be huge in Brazil. And you can see that, you can observe that 2 of these 4 environments, industries and rural, are related to the economy, our numbers, our GDP, our productivity. And the other 2, cities and health, are related to the citizen, to the population, to the quality of life of our population. So we try to relate these 2 sides, the companies and the population. Okay, this was the idea of these 4 environments. Well, this slide, I want to call your attention for two things. First, the numbers, the big numbers inside the circles, which represent the impact of IoT in each environment in Brazil. And the second thing I want to show you is that each environment, we have strategic goals, strategic objectives. This is the way we can focus on in each environment. For instance, in the cities, we have mobility, we have public safety, we have efficient use of resources and innovation. And in each environment, we divide it in objective strategies, okay? Sorry for the slide is in Portuguese because this is an image, okay? And I could not edit it. And finally, this slide summarizes all the IoT study that we finished in 2017. We have 4 environments, which we show in these 4 verticals, and we have 6 transversal issues that we call horizontals. Human capital, international insertion, economic feasibility, science, technology and innovation, regulatory security and privacy, connectivity, infrastructure, and interoperability. And we have 60 actions to make things happen, okay, in the National IoT Plan. These 60 actions are distributed in these 6 horizontals, okay? So the conclusion is that our big challenge is how to calibrate the actuation of government in each intersection. This is a matrix. We have the verticals, the horizontals, and the challenge of government is how to act in each intersection. Sometimes the government should not act. Sometimes the actuation of government is critical. And this is my work, this is our work day by day. Well, in this slide shows you the 4 pillars of our action plan. We have the pillar of governance, the pillar of innovation platforms, the competency centers, and the digital transformation observatory, okay? And we started to work with these 4 pillars last year, 2018. The first pillar, governance, it happened this year. We say that the governance began with the publication of presidential decree in last June this year. All the market, all the stakeholders was anxious for this publication. The idea was this decree have been published last year, but last year was an electoral year in Brazil, so for reasons that I don't know, the decree was not published last year, but only this year. IoT was a priority subject in past governments, and I use it to say that we passed for 3 presidents, 5 ministers, uncountable secretaries, and IoT continues being a priority subject. But in this government, IoT gained more importance, and finally we can we had the decree published. And this is the second important milestone for us. The first milestone was the IoT study, and this was the second milestone, important milestone for us. So it is checked. Our second pillar is the innovation platforms. Innovation platforms aim to bring actors closer to the IoT ecosystem. Okay, so all kind of stakeholders, entrepreneurs, investors, industries, competence centers, government, universities, all of these actors are very important to the IoT ecosystem. And for us, it's very important that all these actors work together. Otherwise, the IoT ecosystem will not grow as it should. We understand that IoT solutions assumes many skills gathered, and this is hard to find in a single company. So the company should join and should cooperate, should work together. About our Digital Transformation Observatory, here we summarize the content of the observatory, which was launched 1 year ago in last December. Unfortunately, the observatory is still not as we wish, because it is static. We would like a stuff more dynamic, but we hope that we can improve our workforce and find some partner to help us improve this observatory. This is the website, sorry, observatoriodigital.org.br. So we need a partner, maybe CPQD can help us to improve and to become this observatory from static as it is today to a more dynamic observatory with all of these contents changing all the time. Well, we have the chambers 4.0. We have, as I said, 4 chambers. And now, each chamber works related to each environment of our IoT plan. So we have the industries chamber, the rural chamber, the cities chamber, and the health chamber. It's important to say that in this new decree, the former IoT chamber changed. Now, the IoT chamber, the former IoT chamber, was only a government chamber, okay? Only for government. So, to maintain contact between the government and the other stakeholders, we decided to create these 4 chambers. So in these chambers, we have participation of academia, R&D institutions, universities, the private initiative, all kind of companies, big companies, startups. So the idea is to put together all of these stakeholders in the same table and discuss the issues, okay? And the result of this discussion will be taken to the IoT chamber, which is only a government chamber, okay? The first chamber, industries, was created last April, okay, this year. And the industries chamber is completely operational, and we already have specific actions for the development of industries. The second chamber, the rural chamber, was launched in last August, and now we have 4 work groups, and we are now defining our agenda for the rural chamber. The next 2, cities and health, we intend to create them this year, probably final of November now, this month, or in the worst case in December, but the idea is to create the last 2 chambers still this year. Here we have an example of initiatives related to interoperability in the Brazilian action. That's 60 actions I told you. This is an example of 4 actions which are mapped in our plan. Encourage and support the adoption of IoT with regard to interoperability, okay? Promote Brazilian standards for IoT solutions as benchmark for international standards to encourage economies of scale of all parts in the value chain. Include in the IoT equipment and solutions accreditation policy, interoperability criteria, and consolidate IoT-related best practice that favor interoperability. So we have at least 4 actions which are related to interoperability, to standardization. And so I'm here to show you this, the importance of interoperability, and to see what ETSI, ETSI is working now. And finally, we have here an example of an effort of standardization and internationalization that we have made, that started the last year, and in this year, we have finally approved the recommendation architectural reference model device for Internet of Things applications in the context of ITU, okay? This was a work of Cesar Institute, together Anatel, and together MCTIC, to do this recommendation, and this recommendation was approved and published with this number, 4460, becoming the first Brazilian IoT recommendation published by ITU. And our intention is that this kind of initiative can be replicated, okay? So this is our big goal. We can, our goal is that Brazil can do a lot of contributions, not only in ITU, but in ETSI and others, so that Brazil can have a important participation in all of these forums, all of these institutions, organisms. Well, coming to the end of my presentation, next steps that we are planning are implementation of the 60 actions, 60 IoT.br actions. We have to align our intentions with the other ministries, which are responsible for the prioritized areas. We call MAPA. MAPA is the Ministry of Agriculture, okay? MS is the Ministry of Health. ME is the Ministry of Economy, which includes the industry part inside. And MDR is Ministry of Development, Regional Development, is the ministry that cares about smart cities. So MCTIC is signing MOUs with all of these ministries to work together. Well, we seek for international partnerships for the establishment of joint frameworks. We are now monitoring the project's execution in BNDES IoT pilots open call. This open call happened last year, and this year the projects are starting to happen. We are following up the issues raised at Anatel's public consultation, mainly about the regulatory issues. And finally, we are monitoring project implementation at Embrapi. Embrapi is an agency of government which coordinates projects, okay? Embrapi has a model of funding where Embrapi can fund 1/3 of the project, of the value of the project. Well, I think this was my presentation. Okay, thanks for your attention. I'm available for questions, and I will be here during all the day, and I'm available to discuss with you in the coffee break and so on. Okay, thank you very much. Sorry about my English, it's not very good. I need to practice just a little bit more.
It was great English. Thank you, Guilherme. Let's invite then Xavier Piednoir to join us from ETSI to come back here and talk to us about Internet of Things. Let's see. Rafael, just trocar por apresentação. Just a moment to put the presentation. Yeah. Well, then Xavier is going to talk about the Internet of Things, its challenges, and how to enable a cross-cutting interoperability and the benefits of a common service layer. Please, Xavier.
Okay, thank you again. I'm going to share with you a few thoughts about how we look at the Internet of Things and what we see as the main challenges and how to address them, or in what spirit we should look at them for our work and our partnerships with others. So we have sorry, what is this one, sorry. We have more and more connectivity. It's spreading everywhere. All the sectors of the industry have now their form of connectivity, and we have connected devices everywhere in our lives. I mean, of course, the first thing we almost all have in our pockets in one or multiple items is the phone, but the watches, the other things are becoming connected. Even some of our health devices are becoming connected. I'm thinking, for example, of pacemakers that are now remotely monitored and even parametered. And so we are now hosting or holding devices that become both a data producer because of the potential sensors it uses and what we do with them, and a data consumer because it needs also other information coming from outside to operate, which sets very clearly how important the connectivity is on one hand and how critical access to data is. And we have in the past years actually moved from, I mean, the IoT, we could say, has been there for a long time, except that technology has evolved. And we had at the very beginning, for example, on the internet, information published about things, monuments, locations. It was a very descriptive thing, a kind of read-only approach where we don't interact with the data. Then we started to have things that were publishing kind of live data, tracking of parcels, and our monitoring of some events was something that we could monitor through our internet connections. Then the next thing we knew was, okay, we had devices that were exporting data, and we could see that over our connections, and it was the start of the interoperability of communication. Then the next step we encountered was the devices talking to each other, and here we reached the stage where data interoperability comes into play. And last, we gave those devices and their interactions a certain level of intelligence, and that's where we have the semantic reasoning that comes into play. As I was saying, connectivity is a key enabler. At the moment, we couldn't be talking about what the topic of the event today is without connectivity. So, as I wrote there, it should not be visible. So it's basically assumed to be available, but it should be there. So it is very important that we have communication technologies that are compatible with the use cases that IoT brings to us. That is coping with a massive amount of devices, ensuring that we have very power efficient protocols and interfaces, and where we also can move from applications that require super fast data rates with super low latency to the other end of the scope, where we have devices that basically wake up only once every few days and will just send a burst of a small data just to say, I'm here, I'm still alive, and my location is this, for example. Let's say a container to transport some goods. And we need to cater for all these use cases. The work we are doing in ETSI, but also with the ETSIs of other regions in the context of 3GPP and working on 5G is intending to address this wide spectrum of activities. So 5G, as we are specifying it today, will be able to, let's say, to operate with low power optimization, with a very large amount of devices for each cell. We are also able to, to configure the 5G network in order to operate with a very low latency, which is, for example, critical for health application or telemedicine applications. For example, if you have some kind of tool for remote surgery, then you want to make sure that things you do as surgeon happen at the same time on the other end. And of course, that needs to come with the necessary reliability in terms of keeping the connections working and not dropping, but also ensuring proper security and data integrity. And then there is also scalability and flexibility in order to be able to move in one area from one use case to another. And this is where there is some very advanced developments with 5G, where the network can be made to behave in one way or the other, depending on the use cases that are required to be fulfilled at a given time. So we have this vision that everybody is talking about, that there will be a super massive amount of devices connected by 2020, that there are going to be some key drivers in the IoT market, for example, with energy and utilities, and then automotive, retail, and there was a prediction of oh, sorry. You know what? I'm moving on my laptop and not moving on the screen. I'm sorry for this. And there's prediction of 4.3 billion devices, 4.3 trillion dollar market by 2024. And this is what we always read, that this will be super huge and everything. It is not actually happening at the pace that was expected. And it is partly due to the fact that it is rather complex to implement those systems and ecosystems that host these devices and that make them talk together. Interoperability is at the heart of what we need to make these systems working systems. And if we want to deliver on that kind of vision and promise that, as written here, there is still a lot of work to do in order to enable that interoperability of devices. But the vision remains the same. We want an Internet of Things that is an enabler for a smart society, that will be a data society to some extent. We want devices to be serving the society and the people. We want to ensure that data flows as it should be flowing, and that there are no artificial hurdles standing in the way of fully exploiting the value of this data. And of course, in order to have that, we need interoperability of data and interoperability of access to data. So next one. One of the big challenges, and of course there are many challenges, but I focus on two mainly here, is the interoperability. IoT brings many sectors together. We have, even simply looking at the national plan that was just presented, there are 4 priority areas that are very different, and they intersect to some extent. And if you look at that from a very high view, I would say at some point we need to, even if these are sectors, they will at some point, they are, or maybe already, but they will at some point overlap. And so we end up connecting players that have never been connected together. And they need to be sharing similar concepts and understanding about how to address the challenge of becoming smarter and becoming connected. And there is a complexity that comes with this interconnectivity, which is inevitable, but which is also something that we should try and make disappear as much as possible. So this is our work as more technical organizations to ensure that we deliver the necessary tools to ensure that interoperability does not come at a price which is impeding the user experience or the efficiency of the systems that are being operated. We have also the challenge of deploying solutions in locations that can be seen as very remote or isolated, and it is, I think, one of the reasons why the rural or agribusiness use case has been identified as one of the priorities in the national plan in Brazil. But anyway, there will be a need for connectivity at some point, which means that we also need to work on the connectivity part for these use cases. And for interoperability, one of the big challenges, considering the amount of manufacturers for devices and solutions, is a risk of a big fragmentation. And in addition, vendor lock-in. So we need to bring this interoperability to deliver these technical solutions that enable interoperability in order to avoid that. The other big issue we see is the security. Today we are more in what we would call the internet age, where we have a data which is captured and which is more relating to our environment and which we use in order to adapt our own environment. There is some kind of indirect privacy threat, and the security issues that come with the internet age, they do not ultimately really impact our safety. But in the IoT age that we are entering, the data which is collected is about our behavior and ultimately is used to change our environment. There is a problem of privacy that we need to address, and there is a problem where issues with security can directly impact our safety. For example, I mean, it's a very, very trivial example, but if you have a remote or connected smart lock in your home, if that thing is not working properly, that means people could enter your home and do what they want. If you have insufficient security on your pacemaker, and we have seen actually cases of attacks in the field, then there could be people that hijack the connection between your doctor and your pacemaker, and then try and blackmail you, saying, if you don't pay this, I will change the parameters on your pacemaker and put your life in jeopardy. So we need a strong focus on security, and we need that focus to take place from the very beginning. We need to have security by design, and not security to be seen as something which is coming as the last minute element in implementation and design of devices, and that is slapped on the finished product like an additional bit, because that approach never works. It needs to be really part of the design effort from the beginning. And at a minimum, we want that integrity of data is guaranteed, and of course confidentiality can be provided where this is needed. And let's not forget about privacy. It needs to be addressed as well. It's not because there will be billions of devices connected that our privacy should disappear with the rise of the machines. So it is not an option to leave privacy aside. And we think it is also key when developing technical solutions, when developing technical standards, to keep that in mind and ensure that the technical approaches that we select do not put that privacy in question. Next one for the challenges for security is also about protecting the critical infrastructures. We have a lot of course, connected devices. I was mentioning healthcare, so this I won't repeat. Intelligent transport, the roadways, the smart connected cars, all of these things are also applications that can directly impact our safety. Smart utilities with metering, the distribution of energy and production of energy, the water, the waste, the food, everything is also critical infrastructure that can also completely disrupt the operation of a city, for example, when attacked. So these infrastructure, they need to have the proper level of security. They also need to be designed with security in mind from the beginning. And we need to take into account as well that these, because we are in the real world, these infrastructures, they offer physical elements where, or locations where the attacks can take place. It's not only about a network thing and everything on computers and communication interfaces. There are also the very physical parts of the infrastructure. For that, we need to have, and we need to deliver the very good mechanisms for authentication, authorization, securing communications, and all let's say the aspects that are needed to have a properly secured system. Next one, and I think last one is the further challenges. For IoT, as I was mentioning, power efficiency is a very critical element. The power management is one of the big challenges. How to deal with the increasing complexity in very heterogeneous environments. And we need maybe to shift from design and thinking principles that have been applied so far, thinking that networks were designed for humans. But now we are designing also networks for devices that have a different behavior. So maybe there are some principles that need to be at least challenged and re-explored in order to ensure that they are still the best that could be applied. And in all that, in order to address these challenges, we think that standards are a very efficient tool in order to address many of these challenges. And we have organizations that collaborate on the globe through this project I mentioned earlier, 1 and 2M, for example, to address these challenges. And Laurent will be presenting more about this later this morning. And I think this is it for this presentation. Actually, I will follow with a very short presentation, shorter than this one. I don't know how bad the time is, which is going to ask some questions and maybe set a bit more the stage for the presentation by Laurent on this effort on 1 and 2M. So the next presentation is about the benefits, or how to try and address this. Sorry, I'm mixing up things. Okay. So yes, we have, as I was mentioning, many sectors of the industry that are becoming smarter, becoming connected, and they need to talk to each other. So we are moving from a world where we had so far independent systems to what I would call systems of systems. where we have a bit bigger ecosystem that connects existing or legacy systems. And we could see kind of a pattern there, where the history is repeating for each and every sector. First, we have a bit of process of optimization, then automation, then connection/connectivity, which have gradually made the systems more smart, but they were still independent systems, just reaching another level in efficiency for that given sector, for that given industry. But then we need to connect systems, which means we start with, usually I'm just connecting to another system, and then we realize, oh, the data format, the data storage and the communication protocol to address the systems, they are different in these two systems. So we need to build some kind of gateway that will translate from one system to the other in order to exchange data. We will also be able to adapt or move from one communication protocol to the other. It could be just one way because one new system is using a legacy system, or it could be two-way because those two systems, they really need to exchange both ways. And then you get more systems that come into play. And the complexity increases very rapidly with multi-way gateways that are needed for this data exchange, multiple adapters and proxies for different protocols, some kind of smart routing between systems, and ultimately a very complex, very costly system in order to make systems work together. And because you probably have to turn to a specific vendor to build this connectivity solution, you have yet another vendor that could lock you in his own solution, which is tailor-made for you. You won't find it anywhere else because each system is different. So this is increasing even the risk of vendor locking. So we need to move away from that. And if we look at that from the data angle, we always say data is the new oil, this is where the value is. So we need to make the most of it. We need to really exploit the value of data. And that means we need to have the best return on investment, I would say, if we invest in the technology in order to harvest the real value of the data. And in order to do that, we need to maximize consistency in the data format, in the way the data is described and identified, and also in the way data is accessed. So, of course, if we develop very sound and a very elaborate technical vision, can probably come with the necessary solutions to do that, but this usually doesn't happen if there is no political vision, no policies backing this in order to make sure that this is also something which is shared at the highest level. And in that respect, I think it was very interesting to hear about the presentation about the national plan, which is showing really that these questions are really identified from the top here in Brazil in order to ensure that some good approaches are adopted in order to tackle the challenge of IoT, which, as was mentioned, is the leading market or prospect market in the future. I would give an example, which is smart cities. Even at the scale of a city, you can have the political backup, the political vision, but each city basically remains very independent. They will drive their own transformation to a smart city, and then later, at some stage, maybe at the scale of the state or at the federal, scale, there will be initiatives in order to share data between cities, in order to collect and aggregate data between cities. And then we will realize that we will again fall in this case of connecting or having a system of systems where we need to translate, we need to adapt, we need to redevelop things on top of the existing in order simply to be able to use the data. So coordination and harmonization is really the answer. And again, standards are here to help. And it is really one of the reasons of our presence here today and our existing exchange with CPQD, which is to see how Europe and Brazil can find areas where collaboration can take place in order to work on these standards and deliver the right tools in support of the policies that are being implemented. So I'm almost done. So what are we building in the end? We are building something which is really complex. It is mixing consumer and industry level devices. It is connecting different industries, and that means different cultures. Sometimes it's even very challenging simply to find a common way to name the same things. But ultimately, we are also building a tool which is bringing society forward. It is really an instrument of progress. It is something that also is really, sorry, again, I insist on the fact that security and privacy need to be embedded in the approach. But if we don't do that correctly, are we building a fragmentation factory, as I would name it? We need, in order to avoid that this become a very, very fragmented system, we need a common way to access a set of services for all of the subsystems, I would say. We need a kind of middleware spanning across silos, and that is removing the kind of barriers existing between them. And we call that the common service layer. And this is what, again, Laurent will be talking about. I don't want to kill the suspense. And the last thing, I was talking about system of systems. So SOS. Is it system of systems or save our souls? If we have the right vision, if we make the right choices and have the necessary support to implement them, if we have a sound technical approach, if we use standards, so maybe we can start build a system of systems the right way. But otherwise, I would really advise that you start learning the Morse code. And that's it.
Thanks, Xavier. Thanks. Let's take a break of 20 minutes, and then we'll be back. The coffee will be served outside this room. It's in the outdoor garden on my right. Okay? We'll see you soon. Thanks.
Mais senhas? Acho que não, ninguém pediu mais. Não, nós vamos para o café agora?
strategy for the digital transformation. Common standards ensuring the interoperability of digital technologies are the foundation of an effective digital single market. They guarantee that technologies work smoothly and reliably together, provide economies of scale, foster research and innovation, and keep markets open. Effective interoperability guarantees that connected devices such as cars, phones, appliances,
Laurent Vellet from ETSI. It's a technical expert in 1M2M. He's going to talk to us about the 1M2M ecosystem. Please, Laurent.
Yeah, thank you. So thank you for this welcome. Yeah. So let's start with this presentation that my colleague Xavier has introduced. I'm Laurent Velez, working at ETSI in the Center for Testing and Interoperability in CTI. But I've got a second cap, which is the 1M2M technical officer. So I'm representing 1M2M in this workshop. Okay, so as my colleague Xavier has explained, we're looking at all the analysis that Gartner and others did. The schedule was tens of billions devices in 2020, but in practice, where we are with this, and I think we are not at this level of a deployment at the moment, and it's not because the technology is not there. I think it's people are scared to deploy IoT network, and mainly smart cities. They are scared because there are a lack of interoperability. And we try to analyze why the deployment of IoT is so complex. And here is an example of smart cities. You can see that smart city is not one domain. It's a bunch of different verticals or with different subdomains. It could be smart energy, smart building, smart transportation. So it's not so easy because it's not one domain, it's several ones. And of course, all these domains, they use most of the time different platforms that are not able to interwork each other. It's like that. People, they don't want to share data. They don't want they have their own work and their own activities, and it's difficult to interwork each other. So that makes challenging to deploy. And also all these domains, they use also some underlying protocol, underlying technologies, and they are not able to communicate. They are not able because the underlying technology are different and they are not able to exchange data, interwork. So here I listed some IoT deployment pain points, and here I listed only what we call the standards. I even don't talk about the proprietary solution that cannot communicate with other by definition. But here's some underlying pain that we have, underlying technology. For instance, for the connectivity networks, we have different standards, cellular, fixed network, Wi-Fi, and other. And if your platform has different way to communicate, they cannot talk each other. It is a pain. Also, the security is different. None of the platforms use the same one, and you can have a common approach for technology, for security. So that means that it's very difficult to deploy and having a different kind of infrastructure on your network. Transport is different. The protocol, CoAP, HTTP, and other, it's also difficult. What we call content serialization, the format of the data is never the same, even if you adopt XML, JSON, or as a format, but the data format is different each time, so it's difficult to really have an interworking and interoperability. Of course, all the network has the platform have a different way to be managed. Here I list some of the standard protocol for managing, OMA, DM, TR69, and also the ontology, the semantics, giving meaning to the data. They all have different ontology and difficult to exchange. So this is really make challenging to deploy an infrastructure, on IoT infrastructure at the moment. So what is the answer? It's something that we have proposed in 1M2M, is to have a kind of common platform to make the make all this underlying technology, this data format, everything, the device talk the same language, and to be able to exchange and to provide interoperability. And of course, we want to have something pretty abstracted in order that can cope with all the technologies. So it is really all this problem that I listed before are addressed by this proposal of common architecture, which is 1M2M. And the goal is really to simplify the life of the IoT stakeholder. So what is 1M2M? My colleague has explained, it's a partnership project founded by the 8 most important ICT standardization organization in the world with a worldwide coverage. So we have ATIS and TIA in the US, ETSI for Europe, TSDSI in India, CCSA in China, TTA in Korea, and ARIB and TTC in Japan. All these standard organizations represent more than 200 companies. So they are, let's say, a regional standard. Even ETSI is more than Europe, as my colleague has explained, because most of our members are non-European. Indeed, we have Cisco, Apple, IBM, Huawei, and others. So, but at least the other one are represent regional, and ETSI is, let's say, a bit more global. And for being member of 1M2M, you just have to be member of one of these organizations. Oops. And so what, just to come back to this, if you're familiar, it is exactly the same model than 3GPP. 3GPP that created 3G, 4G, 5G, exactly with the same company, the same actors, the same, except TIA, it's exactly the same partner that founded that. And the way to work is exactly the same model. ETSI is involved in both. And so if you're familiar with 3GPP, you will not be surprised how it's working. And to make this analogy with 3GPP, is we are trying to use the same kind of model that the mobile has worked. Mobile is the best example for the standards. If you look at how the mobile has evaluated, and now you can use your mobile from any brand, on any network, any place in the world, and thanks to the standard for doing that, this global worldwide interoperability. And we want to apply the same rules to IoT. And this is the 3-layer model that 3GPP has applied for the user equipment, at least, for the mobile. With an Android mobile, you have the application layer, which is really access the connectivity layer via an operating system, which is Android or iOS. Using API, you have the operating system itself that manage all this communication with the application and control, and to provide access to the connectivity layer, which is in gray, the 3rd layer, that provide access to internet via 3GPP network, but also Wi-Fi, Bluetooth, and other. So this easy 3-layer is has made success of the mobile, and we want to apply the same to IoT. For instance, here, if you can see any WhatsApp or YouTube or whatever, when you develop an application, you only focus on the data, only on your business. You don't care if you will use Wi-Fi, Bluetooth, or whatever. You don't care. It's not the guy that developed the Facebook or the WhatsApp application that is dealing with the connectivity layer. And for IoT at the moment, it's different. When you develop an application on Zigbee, on other, you have to know that. And it's not what we want. We want that I develop an IoT application, I don't mind which network I use. And it's for the long term, because the technology will change. So exactly we want to apply the same model. And here, the same model. So as you can see, 1M2M has defined a service layer, which is in the red, which is the operating system. I would say it's Android for IoT, except that this Android can be deployed not only on mobile, but on gateway, on device, on everything. But it's the same model. So you have the application, the IoT application, could be anything. And of course, doesn't take care of the connectivity layer, on the security, everything. The service layer is a kind of toolbox of services, providing services for any IoT application. And when I talk IoT application, it's everything. Sensor, temperature sensor is an IoT application. A dashboard is an application. A car is an application. Everything could be an application in IoT, in this model. And the connectivity layer that distribute independently of the application. So it is really the service layer that provides this toolbox of services. And here is what we listed, the common function that are present for all domain. Because we want really to make an architecture, a horizontal architecture that can work to any IoT domain. Not only industry, not only transportation, for all of them. That it is the goal to be able to exchange data for all the domains. So we identify that these functions are common to all, you know. And because any application need to be discovered, any application need to have semantics for for giving meaning to the data. It's common. Device management, any application need to be managed. So it is really the goal to have that to be able to exchange. Here I listed, I've got a dedicated presentation on security framework, but I listed some aspect to secure the data. I will come back to this one later. But what is important, what Xavier has explained, it's the security. And what we wanted to do is really to have security by design. From the day one, we have a working group security, working with the architecture guys, and really to include security, because security is a crucial, you know probably better than me, but it's important in IoT more than let's say, the legacy world of internet. Internet, okay, when you have been hacked, okay, the impact is on data or information. It's crucial, but it's on information. When we talk about IoT, first of all, the devices are weak, because if you deploy a mass market, you need to have low cost, and you need to have some constrained devices that are not protected enough. They are pretty weak and easy access for hackers. And also, the impact is more than information. The impact is physical. When Xavier was talking about the pacemaker, the impact is not, okay, you have lost your data. The impact is a pacemaker. It could be a traffic light, you know, at a rush hour. If it could be an elevator. This is physical. So we are going to another dimension in the security, and that's why we have integrated the security by design in the architecture. And also we wanted to abstract, like we wanted to abstract everything, we have also abstracted providing API for simplify the life of the developer for security. As I say, also there are different functions, device management. You know, the device need to be managed. So it's uploading the firmware, for putting security patches and everything. So this is common to all. Semantics, very important in 1M2M to provide meaning to the data. I deployed, as I say, 1M2M security service layer can be deployed on the field, on the device, but also in the cloud. But I will come back on this. And 1M2M has defined the red part and the interface to the application and the connectivity layer. So how does it help? I would say this is the current situation, where you have silos. You have silos per domain, even big domain like smart transportation is really a domain. And at the moment, actors are different, and nobody can exchange data with the other domain. They are all in their silos, and even in the silos, there are no much standards, I would say. That means that if you deploy something, you could be locked to your vendor, because you will have an infrastructure, a network. And then if you want to extend, because the technology has changed, as you want to exchange, you cannot, because you will have two networks at the end, because the new technology that you will deploy will not be able to talk to the previous one. And it's really locked to proprietary solution or to a vendor that you cannot change because you will not be able to update your network. This is the silos. What we want to, what the vision of 1M2M is to get this service layer, this horizontal architecture. And the goal is dual. The goal is first to be able, as the data and the way to collect the data will have the same format, the same mechanism, the same primitive for all the domain. I have a common architecture. That means that you will be able to exchange data between domains that at the moment, sometimes they are not obviously linked, but you can because you have an infinity of applications possible. So you can link different verticals and exchange data, which is not possible at the moment. And also, I would say, because it's abstracted from the protocol, this is the key. You can have Zigbee talking to LoRaWAN and other. It doesn't matter, it's abstracted. At the end, the application that run the northbound application, they don't care. And you don't have to have different network and different way to manage your network and different technology. It's abstracted. So you can have any technology. And also, this is the key for the long term, because the technology change, let's say the underlying technology, the protocol change. At the moment you deploy LoRa, is great, 5G is coming, and you will change. But if you do that with this service layer abstracted, you don't have to change your full infrastructure. It's independent of the protocol. And this is the key. And you can also have a mix of different technology. It's independent. And what I would say, this is a vision. It's not another platform that I want to sell to you, okay, mine is better than yours and that. This is a vision. We have listed 400 different service platforms at the moment. And we don't want another one. It is not that. We are a non-for-profit organization mandated by some government to help to promote a unified vision of the IoT. We don't want another platform. There are too many already. So this is very ambitious, but it's a vision that I like to share with you on this. It's another example that is similar to that. The silos, the security, the CCTV, the energy in the building, they are in these silos. If they can exchange data, it's exactly that you can detect that when nobody is in a building, you can switch off the air condition and switch off the light. It's a very trivial example that I like to show, but it's not possible at the moment. And you can have, so just a way to exchange data. So here the architecture, the model that we have defined. In fact, there are two main entities that I will come quickly on that. You have an AI, which is application entity, is the application world. It could be anything. It could be, as I say, a car, a pacemaker, or whatever. And the CSE, which is a service layer entity, the common service layer entity, and it's the gateway. It's where you store the data. Because an application itself could be very constrained, and you don't have to store your data. You have to push the data to the gateway or to the CSE. And the CSE provides all the service that I listed earlier. And here I'm talking about logical entity. I'm talking about software. It's only software. As we are abstracted from the protocol, we are talking about software only in this. An application entity and the CSE can be deployed anything. It's help for scalability. The standards provide you a toolbox. You can do what you want with that. As soon as you follow the rules, which is an AI, push the data with the API that we have defined, some operation that we have defined, and the AI push the data to the CSE. And if you want to have access to the data, you go to the CSE, because the CSE has a representation of the data. And an AI could be a single, to be an application dedicated node, could be also in a mobile. A mobile could be an AI, but it could be also a CSE, depends what you need. It could be in the cloud, it could be in the gateway, and that's all. And for this slide, I would say it's something that I didn't talk yet, but as I said, we have a vision, but we are not only, we have existing platform at the moment. We are not the only one. We are the only standardized one, but at least we are the only one. There are also existing platform at the moment. And we don't want to say that, okay, you replace your infrastructure because this approach is better. What we like to do is you have existing, and because 1M2M has been designed to be the interworking on all the platform, you can use your existing network. And we did a lot of interworking. We have, by design, created an interworking mechanism to talk to all. At the end, we don't mind where is the one M2M. What we want is at least we won't be in the full picture in order to be able to exchange data. This is the key of interoperability. So you have already some existing initiative, OPC-UA, which is very focused on industry. You have OCF, which is more for smart home. They are different, but it's true that none of this forum or standardized way, none of them, they can talk each other. And 1M2M could be really the glue to talk to all of them. And we have also, because of this, our big sister is 3GPP, we have also a lot of relation with 3GPP. And we created, I would say, we have created this standard with NB-IoT and interworking with cellular IoT indeed, where 3GPP deploy NB-IoT, and 1M2M could be the service layer of 3GPP and this kind of stuff. That means here, for instance, you have an application on the NB-IoT device. Okay, we don't use NB-IoT just as a simple transport like we use for Wi-Fi. We take also benefit. We have an interworking. We have defined API talking to 3GPP in order to use NB-IoT network for device triggering, for location tracking, all that. So it's not only transport in this, it's really we use the strengths of the 3GPP network to collect information and manage the data. And most of, some new networks that are deployed are NB-IoT working with 1M2M. It's like positioned at the service layer of NB-IoT. Coming back to this, as I said, interworking is crucial because we have existing platform and we have partners and we are all in the big family and we don't want to replace them, we want to make them talking each other. So we did some mechanism. First, this interworking mechanism for, as I say, upper with OPC-UA or OCF, all join OIC, then it's OCF, it became OCF. But with Zigbee Alliance, we have also some standardized way to talk to Zigbee Alliance. So we can exchange between platforms, I say at the same level, service layer. We have also this very important mechanism, which is here, if you see, take this IPE, interworking proxy entity, which is, let's say, a piece of code that can make the link between the non-1M2M world and the 1M2M world. On the left, you can have KNX, you can have Zigbee, you have LoRa, you don't mind. It is not 1M2M. You can use existing device on the market because at the moment there is no real 1M2M device that you can buy on the market. You can buy a Philips Hue, which is based on Zigbee, but it's Zigbee. But with this piece of code that we have standardized, you can make it work with 1M2M. That means that for the rest of the network, it's an IE, it's 1M2M. That means you can manage, you can use the same security. You don't have to even have a 1M2M native. You can have a 1M2M native application, but you don't have, because you use this IPE to work with any existing. And I can tell you that I think 90% of the network deployed at the moment on 1M2M are with LoRa. LoRa 1 is cheap it's cheap and at the moment it's okay. You deploy LoRa 1 and you work with 1M2M as a service layer. And for the network, it is 1M2M end-to-end, but it is the way that it is doing that. I will go briefly, but as I say, an application is always connecting a CSE, and you request an operation, you verify that you have the right to do it, and then you reply. So it's very client-server. It's RESTful API. If you're familiar with RESTful API, that is commonly adopted worldwide, it's exactly a RESTful API. I will not go deeply, but this is a kind of representation of the resource on the CSE. As I said, the IE doesn't store the data. IE is a simple application, very basic. But IE represents itself on the CSE, on the server. That creating different resources, RESTful resource. And if you want to have access to the data of the AI, you go to the CSE. It's this way. Because an AI, if it is basic temperature sensor, it cannot be accessed. It's not a web server. It cannot be accessed easily. It cannot store the data. So why contacting directly a constrained device where you can contact its representation on the server? Here, just an example of a temperature sensor that push the data to the gateway, and no, it's not that. It's this one. Yeah, and it create the representation, a container saying it in a room, and then the value of the temperature. And if another application, a mobile application, want to read the temperature, it will go to this value, which is on the CSE, never on the AI. As I say, it is scalable because an AI and the CSEs are logical entities, so they can be deployed anywhere. I'll go quickly on that. I will spend a few times on the benefit of M2M because, as I said, there are many platforms, and I like to list at least why this approach is a bit different than the other one. Just a summary. As I said, it's independent of the protocol. That means that if it's abstracted from the protocol, it could be applied to any technology. You are not linked or not tied to one protocol. And it gives some flexibility because with the same service layer, if you want real time in industry, I know that it's very helpful to have DDS, but if you want to have a connectivity sensor at the top of a building, you need very constrained device, you use CoAP. You don't mind the protocol because you have this abstract service layer. And also it is very good is, as it is abstracted, the technology can change, as I explained. ZigBee could be replaced by 5G and other, you don't mind. You don't have to change a line of code in your application, in your infrastructure, because it's abstracted from the protocol. So for the long term, it's important, and it is the key for M2M, because IoT is a long-term network. It's not something you will change. When you deployed sensor, you deployed not 2 sensors, you deployed thousands of sensors. So when you deploy once, it's not something you will change regularly. IoT is different market than the internet market or other. IoT is by design done for long term. And when you talk about long term, you need to consider an abstraction because on the long term, the evolution, the technology will change. And you need to be able to have different technology, different protocol, or the new one in the same network. That's why it's crucial on the long term to have independent of the protocol. When you deploy your smart city, it's for 25 years minimum. You don't deploy for 2 years. You will not change. Okay, I do LoRa, and then I change completely my network for doing 5G. No, it's not the way that it's working. So this is, if you want to know only one thing about M2M, this is crucial for me. Horizontal platform, I would say, as this is the same mechanism for accessing the data and retrieving the data and storing the data has the same format. When you develop an application for one domain, you can reuse the same code. It's always the same mechanism. It's same API, so you can reuse the code and deploy many easily. As I said already, integration with the existing one by design, and this interworking stuff that has been done in a way that you can co-locate with other technology or other platform. Data sharing, very important, just to give an infinity of application possible, of domain that you even don't think yet, but later you will say, oh, it's interesting to mix transportation with ELs, for, I don't know, you have many applications possible, and it's done by the way that you can share data. Open standard to avoid the lock-in. This could be deployed on any platform, on any cloud. You can host that in Amazon and then changing. You are not locked to any vendors, any cloud, any person indeed. It's worth mentioning that there are several open source implementations. You don't have to take commercial. You can take open source, and even that you have choice. There are at least 5 different open source implementation, which is depends on your needs. It's very good. And also very important, it is a standard. So it's not a forum with 2 companies or 3 companies that has decided to do something very interesting. It's done by 250 or 200 companies. It's done in a way that it's not linked to one company. If the company that has created the technology is bankrupt, most of the time you lose all your investment. Here, if one company disappears, they have 200 others, and it is not linked to that. It's an open standard. So standard is done in a way that you are never locked to one company. Important, we are transposed and internationally recognized by ITUT. So our specifications are transposed under the series Y4500. So for us, it was a great achievement to be recognized as an international standard. And it's open. You don't have even to be member to have access to that. It's all the standard, all the specifications are publicly available, even the draft. You can have access to everything. So yeah, this is very important. The goal is to get rid of the fragmentation of IoT work that my colleague Xavier has explained, and it's a long-term solution because it's independent of the transport. Some backup. Yeah, I listed some implementation, but I will come back to this. This is some features that you will have the slide, I think. So I give you this slide for information. The different features we are working on release 4. So since 2012, we can say that we are pretty mature now, I would say. There is a certification program. I will come back in a minute on this one. And on this web, the 1M2M web, we have 2 main menus that are very interesting. The specification, where you have access to all the specification and the draft. And you have this developer corner, where you have some developer guide, some information, and open source tools, and that's very helpful also for developing an application. Okay, so I finish with this one, I think. Yeah, I finish with this one. Are we good in time or? 5? Only 5? I've got 2 other presentations. Okay. Yeah. Have you got question? It was clear. Haha. Is my next presentation, but I can go briefly to the next one. So, just to explain, to answer to this question, to the testing and certification. Yeah. The next one is certification, testing and certification. Yeah, we have a certification program, so thank you for this question. In fact, we have a lot of, I will go briefly to this. Yeah, we have this mechanism for the testing. I mean, it's common to all, but we gather the requirement and we define some product profile. Depending on some existing market, Correa, as I can say that Correa is very mature, and the 3 main operators in Correa, they have adopted 1M2M, they commercially deployed, and they provide us a lot of input, a lot of use case and requirements. Then we develop the test specification. It's internal, 1M2M deployed, the test specification, let's say in a text file, and then we converted here in the TTCN3, which is a language for running testing. It's a language standardized by ETSI, but it's worldwide adopted as a testing language. It's, I mean, the certification in 3GPP is done by TTCN3. OMA also is doing a TTCN3, so it's pretty worldwide deployed, and it's it's a kind of executable code of this paper version, let's say, of the testing. And then we have this validation phase. And sorry. Yeah, this certification program. So it started, first it started in Korea, where TTA, the equivalent of ETSI in Korea, has provided this certification for at least 2 years. And it was a logo program. It's not something that mandatory. You cannot use the technology because you are not certified, like it could happen to some other organization. It's a logo. It's if a call for tender or if a government asks you certification, you can, but it's not. It's just to be used to be confident to go to the market. So there is this website 1M2M Cert, which is a list done by TTA. But the recent change is in July, GCF has opened a certification program based on our spec. I mean, GCF is just, if you're familiar with GCF, GCF is doing the certification for 5G, 4G, I mean, all the mobile that you have in your hand has been certified by GCF as a certification body. So GCF also has this recognition to take our testing. They do the certification and they ask to their lab, I mean their accredited lab, to run the certification. So at the moment there is no problem to be, indeed everybody could be 1M2M certification body, but what we like is one GCF, one organization is the global certification, and then you can have accredited lab everywhere. We have accredited lab in Europe, and we have accredited lab in Korea at the moment, in Japan also. I love to have some accredited lab in Brazil and other, just to have that. But I think the best is really to, to contact GCF, to join GCF, to develop. When you want to be certified as a product, you want to be certified, you join GCF, you develop the test plan, what you plan to do, what feature you support, and you will run the test only on the feature that you support, for instance. You execute your plan, you get the result, and then you get this GCF certification. It is the process that has been done. I think for the moment it's free to be certified if you have a product. You can be certified your application, and you can also certify your CSE, your server side or gateway. But GCF doesn't write the spec. 1M2M is providing the test specification for interop and for conformance. So I don't know if you're familiar with the difference between interop and conformance. If not, I can just, I think I've got some slide on that. Conformance is just you test versus a system under you are a system under test, and you test versus the test system. So you really test all the component of one. For instance, you want to test one feature, you test this feature. You list all the requirements in the standard. If I need to, if I send that, I shall have this response. You check everything. It's very unit testing. It's very it's a unit testing, I would say. And the difference with interop, it's more you check the functionality end to end. It's you see that the functionality is accomplished. You don't know how it's done. You don't know how it is. Which message you send doesn't matter. As soon as your functionality is accomplished, if you want to trigger an action and you have this action, it's interoperable. And of course, if it's badly coded, you will see it may work, but with another one, it will not work. So this is more the functionality that is accomplished. It's more system. And both are complementary. That's why GCF is doing both, interop and conformance. Because you could be conformant and not interoperable. If the standard is a bit ambiguous, if the standard say the message should have a value of 1 or 0, okay, it's a bit ambiguous. If one product send always 0, it is conformant. If the other product accept only 1, it is conformant, but both they will not talk each other. So that's why I said it's very complementary to have interop and conformance. But I would say interop is more when the standard is not enough mature, when you have this kind of ambiguity, 0 or 1. When it is pretty mature, then conformance is better, definitely. Claudia, are we okay? Or yeah. If you have any question, please.
Well, for the importance for our event, this standard 1M to M, if you want to make questions, we are going to open to some questions of you. João from CPQD.
Hi, my question is regarding, we have different open or not open IoT platforms. For instance, we have developed one based in European standard like fireware. So, and we can name any other IoT platforms. How, I couldn't understand how this fit together with 1M to M, so you can cooperate with the other middlewares that are going to connect a lot of things. If I missed something, but is that my question?
Yeah, like in the diagram that I show with many other, with Thread, OCF, and other. Indeed, as an organization, we have some of the time, we have companies in both. Members, we have companies in both. For instance, OCF, we had a Qualcomm, which is involved in OCF, that's funded OCF, but also Qualcomm is very active, so they make this kind of glue, and we work with this organization to define a standard, to define a technical specification, explaining how to map all the message and really to have this interworking. This has been done with many, and there are more to come. Zigbee Alliance, there are many different, so I don't have in mind all, but for fireware, we don't have yet a specification, I mean official specification, but we have defined some generic mechanism that if fireware or 1M2M want to follow, they can really, it's open. And I remember that every year we did an IoT week in ETSI. I remember I saw an interworking with fireware and 1M2M, and it was pretty okay. It's not standardized, but it's done, and it has been done, at least I can tell you it has been done in the IoT week on one European project. So it's still that we need companies that come to both and they talk each other, and then you put on the paper, or it's possible. And really, we want it to be the glue with all, and the way it has been thought, 1M2M, is really to make this interworking, some generic interworking with the other, which are not considering a competitor, they are considering a partner. So it's very friendly and open family.
Any other question? Yeah.
Henrique from FACT. Hi. You show a feature of 1M2M that is device management. You have a use case that can show us OTA upgrade, over-the-air upgrade?
For the device?
Yes.
Yeah. Also, for the device management, we have specification that standardize this. All this with the different organizations. We have worked with BBF, we have worked with OMA. Indeed, OMA was part of 1M2M until a few years. I mean, then when they changed their name and their scope, but before that, they were really part of 1M2M. So we have worked with them to use their existing network. Some operators, they have already OMADM or lightweight M2M. They don't want to have another one, so they use the same infrastructure to be able to manage. So we have defined resource management object, or all the mechanism that you are able to over the air or whatever, to manage your device using lightweight M2M, for instance. It's not a problem. We have worked with them on this.
Thank you.
And we wrote spec, but also on their side they have defined specification in order to work with us. So it's really a collaboration with the OMA or other. And you can use existing one. You can also manage natively your device using one M2M. It's possible. There are different ways. We want to be flexible in order that everybody can use it. Because if we want to be the single platform interwork with all of them, we need to have some flexibility, not to impose one technology.
Thank you.
Yeah.
Hi, this is Thomas from Unicamp. I would like to know the size of the group for performing the certification process with M2M, one M2M.
Yeah.
How many people you need and how large it is?
How large? I don't know. As I
Could be a
maybe
group, a remote group or a group here in Brazil. How would be the minimum that you need?
because 1M2M doesn't provide certification itself, so I don't know. What we do, we write the testing given to 1M2, to GCF, for instance, and GCF has this accredited lab. They have a huge network, so we are not GCF, and we don't provide certification ourselves because we are non-for-profit standard organization. It's not our deal to certify product, and also we don't want to. We want to be fair to all the members. We don't want to, no, you are not certified, you are, it's not like that. We do the technical part. The certification is done by specialists like GCF. It's a huge, it's also a non-for-profit organization, but it's huge. Maybe Xavier can help, but GCF, it's 100 of different, the members of GCF are huge. And they have, because they do the 4G, 5G, so they are a worldwide presence, but they are very open to have an accredited lab. I think at the end, only the accredited lab is earning money, but GCF is non-for-profit, so just have to fulfill the rules of GCF. But again, I don't know, maybe I'm sure you know better than me on this. I'm taking care of the standard itself, so, but maybe some of you can answer on this.
Well, I think we can talk later on, Laurent. Thanks very much. Let's move then for the panel. We have a message from, please. We will start with a message from Carlos Oliveira. He is the Minister Counselor of European Union delegation in Brazil. He was not able to be with us, but he sent us some words, and then we are going to, Rafael, it's with you. The next. Yes, we will start with Carlos Oliveira, European Union delegation in Brazil. Yeah. No.
Good morning, ladies and gentlemen. My first words are to congratulate the CPQD, the Brazilian Research Center in Telecommunications, and ETSI, the European Telecommunications Standards Institute, for the organization of this event. I would love to be personally present, but a busy agenda does not allow me to join the interesting debate that will be taking place in Campinas. As you know, the digital single market is a key element of the European strategy for the digital transformation. Common standards ensuring the interoperability of digital technologies are the foundation of an effective digital single market. They guarantee that technologies work smoothly and reliably together, provide economies of scale, foster research and innovation, and keep markets open. Effective interoperability guarantees that connected devices such as cars, phones, appliances, and industrial equipment can communicate seamlessly with each other regardless of the manufacturer, operating systems, or other technical components. In its 2016 communication on ICT standardization, the European Commission identifies a list of priority building blocks for the digital single market where improved ICT standardization is most urgent, such as 5G communications, cloud computing, Internet of Things, IoT, big data technologies, and cybersecurity. Areas such as e-health, smart energy, intelligent transport systems, and connected and automated vehicles, including train, advanced manufacturing, smart homes and cities, and smart farming, will significantly benefit from the proposed prioritization of standards as they rely on the essential building blocks identified. IoT, Internet of Things, provides a very good example of the transformative potential of digital transformation. This is the technology that connects objects to the Internet, from household equipment to wearable electronics, vehicles, and sensors. Besides the relevance in many industrial applications, IoT is also useful to address many societal challenges, including climate change, resource and energy efficiency, aging, and health. As you know, EU and Brazil are already working together by funding a number of IoT pilot projects dealing with topics such as manufacturing, water management, health, and well-being. These are part of the Horizon 2020 joint projects and represent an investment of 9 million euros, about 40 million Brazilian reals. And we look forward at the results of these projects as a way to assess to which extent IoT can really bring tangible benefits to real-life problems, and also how they can really translate into benefits also for standardization activities. To realize the potential of IoT, we need an open platform approach that supports multiple application domains and cuts across silos to create competitive IoT systems. This requires open standards that support the entire value chain, integrating multiple technologies based on streamlined international cooperation and built on an IPR framework enabling easy and fair access to standard essential patents. In addition to the technical discussion of the standards, it is also important to reflect about the process of standardization. It is a matter of improving the focus, agility, and efficiency of the standards setting in ICT. We need to consider new approaches in standardization, such as promoting community building, attracting new sectors, promoting open standards and platforms where needed, strengthening the link between research and standardization, including testing of the standards, promoting consistent application of standards and their uptake by the market, developing, when needed, certification schemes. We understand that Brazil and its national standardization organizations, notably in Metro and Anatel, are reassessing the approach to standardization. The European Union and European standardization organizations, such as CEN-CENELEC, and especially in this area ETSI, are encouraged to closely link with Brazil in view of sharing their experience and, together with Brazil, promote international standardization in the key areas of the digital single market. The announcement in June 2019 of a free trade agreement between EU and Mercosur is another important development that makes even more relevant working together towards common standards for the digital single market would include a wider economic space. The cooperation between European Union and Brazil in standards is also a major topic of the upcoming EU-Brazil dialogue on information society and digital transformation that will be held in Brussels in the coming week, the 25th and the 26th November. Wishing all the participants a productive meeting and fruitful exchanges, I look forward at knowing more about the findings and conclusions of this event. For us, this is part of a wider strategy of engagement with Brazil in the context of the EU-Brazil strategic partnership. Wishing you a pleasant and fruitful day. Please accept my compliments and look forward to knowing more about what you have been doing during the whole day.
Okay. Thank you for the Carlos Oliveira. And I would like to invite Augusto. Augusto works with us here at CPQD. He's an IoT expert. He worked in our IoT National Plan, and he is going to talk to us now.
Okay, thank you, Claudia. Hello, everyone. Firstly, I want to thank you, Xavier and ETSI, for this opportunity to work together in the project, Indico project, that is international digital. It's too low. I raise my voice. Okay. In this international digital cooperation, first of all, I would like to come back some highlights to IoT National Plan that Guilherme presented to us to emphasize that some important objectives. First of all, okay. First, there are some strategic objectives that we found in the study of the IoT National Plan. That is improve and disseminate financing and promotion instruments for ICTs and innovation companies here in Brazil. The second one is the internationalize local solutions in line with global and interoperable standards. This is so important because we know in this study that if you wanna that our products be participating on the international solutions and integrate very well here in Brazil, we need to follow some standards, national standards. So it's as an important thing that we found in this study. It's reflected in the IoT National Plan that was published in the decree mentioned by Guilherme. And finally, too, I want to emphasize that there was an initiative in all verticals, or health, smart cities, industry, and rural, that promoted the adoption of locally developed solutions for environment challenges. In other words, the government, Brazilian government, has set that the importance of the solutions national here in Brazil. I choose 3 projects to basically show some projects that will implement the IT pilots that we are working here in CPQD. That is a worldwide implementation. The first project is about the health sector. We had some problem in the childhood obesity that affects more than 1 in 3 school-aged child in Brazil, Greece, and Spain. We have a project, the name is Curado, is a project co-funded by the European Union and MCTIC. The main goal of this project is to promote the prevention of the obesity in the early stages of the life. Don't attack the problem after the age is after. So the promotion of this prevention is based on IoT solutions that we're monitoring all the child in school age in the pilots. That is one in Athens, Fortaleza, Ceará, and Madrid in Spain. The solution, it's important to see that first we have all these actors working together. IoT for us is not only one actor project. It involves a lot of actors working together, and this is the architecture of the solution. So we have here the context monitoring from IoT physical environments, the wearables and physiological behavior monitoring the child, health information of the community, and the open data that could be done by acquiring the data from the smart city solutions. So it's a typical solution that could be in the cross 2 sectors, of smart cities and health. So after that, there's a layer that we put the data information all standardized to the consumer of the application. The child will have the approach with gamification to verify that the benefits of the solution. And we had an interface here with the professionals, healthcare, personal families, tutors, parents, and relatives. To change the model of the obesity, we can, in this way, get more effective of the solution. The second case project that I choose is about the rural project here in CPQD. Is a project there are so many actors too, that is about the promote the productivity, increase the productivity of in the farms. Here is the architecture. We follow the ITU Y2060, that is the architecture, IoT architecture. And we had a device layer with the devices vehicle, pest sensor, weather station, and weight sensors and vital signs. So this is captured, the information is captured by a connective layer. We choose the LTE 250 megahertz until 700 megahertz and LP1. So after this acquiring this information is arrived in the middleware IoT CPQD middleware dojo, and it's a basic cleanup that is available for all applications in that you can make some arrangements with another companies and all kinds of applications with this data. we have here a security layer in all layers, supporting all layers with blockchain. This is a architecture that's all the farms available. And we have a case that is São Martinho. São Martinho is a huge sugar energy group, as one of the 10th of the world. And the agriculture area is 300,000 hectares, is biggest than the Luxembourg country, to make a comparative. So it's a huge company here in Brazil group. And this is a solution specific from the São Martinho project. We had the CAN bus sensors, RFID, GPS, trip computer, and cameras in the device layer. And we had a smart vehicle terminal in to process storage and communication. And we had the base station to connect it with LTE 250 megahertz. And 4G for the whole farm. So with this solution, we had 4G with data voice and video to all the farm. Before this project is impossible with this with the technology. So all information came with Dojo to online consolidation, storing, and processing. And we had access from the operation center and applications that could be implemented to better operational service on the farm. Last one could be a video. The last one is I'm sorry about time. Last one is another project that was the project about cities, is edge computing to verify the license plates online. These are to deploy of innovation solution for smart cities, applying computer vision in edge computing approach. We had a video. Can you?
Presenting the new Qualcomm reference design using the Snapdragon 820E processor. This product is the result of a project developed by the CPQD Embrapi unit for Qualcomm Brazil. It's a complete platform able to help developers accelerate the creation of several embedded software applications, including advanced computer vision. The reference design offers a wide range of resources, such as USB 3.0, HDMI 2.0, Wi-Fi, Bluetooth, GPS, Ethernet, audio, modem 4G, LCD, camera, and SD card. The processor and its main digital resources are located on a single SOM, System on Module board, making it easier to add new capabilities to existing products and reducing time to market for the development of new applications. Another result of the project was the development of a vehicle monitoring application using the resources available on the SOM board. This solution is being tested in the field. Based on local processing of computer vision technology, the license plates of all vehicles are recognized, and only one image is sent over a 4G network to the central server at City Hall. This application using local processing offers significant advantages compared to the most common option currently on the market. For example, it does not require inductive loop, reducing installation and maintenance operating costs. The A20E SOM reference design makes it possible for product engineering to add value and accelerate the development cycle. It's perfect for applications that require edge computing performance with embedded artificial intelligence, low power consumption, and high processing power. This project was made feasible with resources from Qualcomm, Embrapi, and CPQD.
To finish, I want to say that this project is a very important project because the edge computing, this allows the reduce the time to deployment of the solutions. We don't need to put a landed Linux broadband to do this work, this application. And another one, we can do this application with straight a narrow band of this. We don't need to send all the video to do the processing in the center. We do the processing in the edge. We only just send one picture to each car. Okay. I would like to thank you for in concluded that we are adopting IoT solutions here in Brazil. In many projects, we follow, seeking to follow the world standards, not alone, but with all partners. Thank you. Thank you.
Please, Professor Christian from Unicamp is going to make some remarks about IoT for us.
Thank you. So thanks for the opportunity of sharing some thoughts on these three letters. This IoT. Okay, so first I will just throw out some thoughts on things and some thoughts on internet. So I think it was clear through the presentations that there are several IoT silos, that there are domains. So what is the meaning of IoT? So if someone tells me he works on IoT, it's hard to follow up without understanding what things, which type of things, in which domain do you work on. I think we are still far from this vision of an Internet of Things. I don't know if we'll even reach such a universal Internet of Things because of the diversity, the heterogeneity of things. Sensors, vehicles, and all of them are have worked out in different fora, standards, and there is a rationale that the things are not the same. So there are fundamental differences in wired versus wireless sensors, battery power versus unlimited energy, and this has foundational differences that we need to understand and that we lack a framework that we can all agree on. Okay, so we need this scope and this focus to be further developed. So this thing is not working, so if you can pass. No. Okay, the second thought that I wanted to share with you is the internet. So cloud, edge, we just listened to edge, and I'm seeing little standardization focused on IoT edges. I believe the edge will be a critical part of the puzzle. What and where is the edge? Automotives, they regard the edge inside the car as the gateway. Other mobile operators consider the edge at the radio base station. So For some IoT flavors, I'm using this term flavor to recognize that there are these different IoTs, domains. The edge will be critical. Without the edge, the IoT application won't work. When it's latency sensitive, where there is a lot of data to be processed in a timely manner, we need solutions that have advanced computation at the edge. And it's a strategic piece who will operate this edge. So certainly the standards that apply to the edge part of IoT will be very relevant. And there is a lot of added value beyond doing gateway, by doing just protocol translation. So there is analytics to be explored, security and privacy. We have heard also how important they are for IoT. So you need gateways that provide maybe data privacy, data security that the end device cannot provide because of its own characteristics. Performance, for sure, hardware acceleration solutions, interoperability, the point where one standard will interoperate with another one, maybe some protocol translation. So APIs to third parties, for sure, if you want to monetize your edge, your sensors, your things, not only to a customer, but maybe to multiple tenants, how these APIs could look like. And there is related work at ETSI. It's the Multi-Access Edge Compute working group. And I wonder whether there would be an IoT MEC app platform to be developed so that the IoT developers can place in these MEC servers, in these MEC locations of operators, their apps. And that's all. These are the thoughts that I wanted to share with you. And with the panel later, we can go further. Thank you.
Thank you. I would like to invite Professor Akio from Unifesp and USP. Please, take a seat. Está lá em cima.
Good morning. First of all, thank you for this invite. I represent Mr. Professor Moacir. He is the coordinator of NCP in Brazil. Here. Okay. NCP is a national contact point, and the mission of NCP is to inform and increase awareness, provide extensive advisory and training for research community, in special for Horizon 2020, and sign and cooperate for and the potential assistance for participants that need your initiative. And NCP, these areas listed by European Community, National NCP, Legal Finance, SME, Access, and have several areas. I don't talk about all areas. And it is the activities that USP is doing in Brazil. Então, dialogue and steering committee and cooperation with the European Union, organizing info sessions at universities and researchers, interact with EU delegation and member states embassies, attend NSP meetings organized by European Commission, and interact with university research centers and company too, and sectoral events. Brazilian institutions are not eligible for funding from the European Commission, but it's possible to participate using the scheme established by FAPESP in São Paulo and another research foundations in Brazilian is following FAPESP. And also another mechanism is gas research on European Research Council, collaborative calls, Erasmus, Marie Curie actions. And I think that the Horizon 2020 has some opportunities in several areas for IoT, hardware, software, and communication. And thank you. I wanted to talk about this.
Roberto Panepucci from CTI is going to give some messages for us too.
Hello, good morning. We are going to be presenting tomorrow, actually the team from Xavier from ETSI, right, is going to be presenting tomorrow a tutorial, and the day after tomorrow a hackathon on IoT at CTI. So you're all welcome. We reserve some spaces from people attending here. If not you, please tell your colleagues to sign up at the CTI website right over there. And this is being sponsored by the European Union through ETSI, the Indico project, and with help from CTI and FACTI. So with that, let me move on. Yeah, I guess this thing is not working, so I'm going to need your help switching. So I'm going to tell you a little bit about the activities that are related to IoT at CTI. CTI is on a nice campus located on the road, Dom Pedro. Activities are framed within 4 focuses at CTI right now, aligned with the federal government priorities: enabling technologies, e-government, health, and industry 4.0. As far as IoT-related projects, I'm going to mention some things on the area of network, the physical layer. We're not really service-oriented, being a research institute from the federal government. We're more connecting with industry, providing mechanisms for them to add value. So we, in addition to networking, IC design. For instance, we developed a IC for hardened IC for satellite communication using the space-wire protocol. We do a lot of work on sensors and biosensors, from the fundamental up to applications. Security of just cyber security in general, but security of nodes that are working on a network, such as an IoT network. What we termed a human cloud interface, and by that I mean your standard human computer interface, accessibility technology, and then also ontology. How do humans relate to asking things on the internet? So those things fall under that category of human cloud interface. And then a project that we have together with CPQD, which I believe CPQD is going to talk a little bit about. If not, I have one slide, which is the IoT. Okay, we can switch over. We're doing this together with industry by pushing for a more open mode of operation, where we have our facilities open to companies, academic users, startups as part of companies, being able to use services and actually go and do activities. These 4 are already set up: the 3D printing, the packaging and integration laboratory, the photovoltaic laboratory for building integrator or custom photovoltaic applications, and the micro and nanoelectronic devices. There's more coming. Switch over. So enabling technologies involves a bunch of things that are applied in the IoT technology, such as photovoltaics, photonics, nanomaterials for sensing and energy harvesting applications, to name a few. We can move on. We do have the integrated circuit design. As I mentioned, the circuits that are hardened to operate in satellites. Those are implementing some communication protocols, but also photonic integrated circuits, general integrated circuits, and MEMS devices. And we do have an activity that's interesting because we see IoT as being an area where you're going to deploy hundreds, thousands, millions of devices. The environmental soundness of this solution, meaning they shouldn't pollute the environment. It should be have a chain of reverse logistics to recover the relevant materials in place. So we have been working on those activities. We have a project approved with the European community on the Aramin project for recovering lithium and other materials from batteries, for example. We just finished a project to recover gold, silver, and other things from electronics. It's important to have that into account. We do have test qualification, certification laboratories with many partners that do those types of activities here. One such example, noteworthy of the type of conditions to which IoT devices are subjected, is the voting system, which is needs to operate, networked all over the country, and needs to be turned on every so often. And we've, since its implementation more than 10 years ago, discovered issues with batteries, capacitors, LCD screens, all sorts of things that don't operate as normal off the shelves that you turn on and off every day. We can move on. Those are some examples. The Plat IoT project, which is led by CPQD with funding from the ministry, has many different layers, demonstrating applications in a wide range of areas. And CTI is focusing, together with the foundation, on the integration of sensors into viable applications, generating some case studies in the health and ambient, what do you call that? Yeah. Environment, yes, thank you. Yes, Mandaba. And then we have, like I said, a strong activity in security of networks, in particular security of the voting system is something that we contribute to on an, if not annual, every election basis. Right now, I think our team is in Brasilia, overlooking the public test software. And in general, that type of activity, I think that pretty much sums it up. Yep. And that's us. And again, going back to the first slide, tomorrow we're going to have the tutorial and workshop. So thank you.
Finally, José Humberto from Anatel.
First of all, I'd like to thank for the invitation to be here. I'm so glad. I am representing Vinicius Caran from Anatel board in Brasilia. And now I will talk a little bit about the public policy and some regulations for IoT and another things, okay? Anatel is a regulatory agency, the first regulatory agency created in Brazil. And it is responsible for regulation and regulation in telecommunication. But there are another important things here, that Anatel is not responsible for public policy. Public policy is the responsibility of Ministry of Science, Technology, Innovation, and Communication, or MCTIC, okay, MCTIC. And Anatel has office in all state capitals of Brazil. We are talking about 1,600 employees. Anatel main goals are regulate the telecommunication sector efficiently, promote competition, promote telecommunication development, promote quality of service and quality of experience for consumers, manage frequency spectrum, certify and approve telecommunications devices. A lot of things. And, okay. Now we have a lot of, or a complex environment. Okay? Anatel is following very closely the chance lost by Industry 4.0, characterized by a set of technologies which will merge the physical, digital, and biological worlds. A lot of merging in these points. We are we are studying to regulate this complex environment. Okay? Now Anatel has IoT trends. Service licensing, spectrum, network and devices interoperability is very important this point in this discussion. Okay? We have standardization here. Okay? And now we're working to 5G. Public consultation 35 has just finished. Anatel has been analyzing the contributions, okay? But the main points or main trends are reduce regulatory barriers to the expansion of IoT and machine-to-machine applications. Service licensing, frequency spectrum management, consumer rights and quality issues. About service license, Anatel will contribute to new general authorization regulation to provide service. Is one trend. Next, new general licensing regulation to license stations and terminals. Okay? Enable business models in which the tax issue is very, very important because it's a barrier to development of IoT. We propose proposals to dispensing licensing for IoT and M2M terminals. Propose changes in a complementary law to exclude IoT M2M services from state taxes, because in Brazil we have a specific taxes for telecommunication devices. We're talking about 25 for services, okay? Talking about 25% in taxes for services to offer services. Is a state tax. Is very, very high in our opinion. And a legislative proposal to reduce the value of inspection fee in the licensing of IoT M2M terminals. Okay, for us, it's very important to reduce taxes to provide a best service, which are very, very good price to the consumers, to the market. Now we are working very, very hard about the frequency spectrum auctions for 5G in the next year. We're talking about a proposal, and this proposal is under analysis of the board of directors of Anatel. We has just finished field tests to evaluate the interference between 5G, 3.5 gigahertz, and the C-band, because here in Brazil, we have very, very close to this frequency, the television will receive only. We are studying the interference in this between the systems. Okay? Frequency spectrum auctions planned for the first half of the next year. We are working to do that. And very, very important, we talked about in this event, we talked about connectivity. And Anatel is very, very worried about that, and we have a plan called Telecommunication Network Structural Plan, in Portuguese, PERT. We are talking about the promote the expansion of access and the use of service with adequate quality and prices. Promote competition and sustainability in the telecommunication industry. Spread of sectorial data and information. And here is important, expansion the transport networks and expansion the access networks to provide connectivity to the IoT devices. Deployment of essential public network. We are talking about health, security, defense, research, and development. And finally, the most important trend is promote consumer satisfaction. And that's it. Okay? Sorry for my English, because my first time talking in English in a very, very good audience. Okay? Thank you.
Xavier is going to moderate this panel. It's open to questions for you.
So thank you everybody for your presentations, for your questions as well. I think it's very interesting to note that in many of the presentations there were clearly aspects that highlight and show that there is the existing good relationship between Europe and Brazil for especially for research and development and research and innovation initiatives and projects. We are here looking at with this project Indico and with our presence here, we are more looking at the standardization aspect of this collaboration, trying to expand that, I would say, to the level of the collaboration in research and innovation. And I was wondering if you have identified in your own personal involvement in these R&I projects inputs that would be relevant for standardization and that would kind of feed that collaboration between Brazil and Europe.
In my opinion, it's very, very important to the relationship because, in my opinion, it's not a personal opinion now, in Brazil we have a lack of standardization in telecommunication. Okay? We need to provide a very, very good standardization or specification in telecommunication, especially when we are talking about interoperability. Okay, it's very important for us. I think it is a partnership and ETSI. Anatel, MCTIC, and CPQD is very, very important for all of them, all of you, okay? Very, very good. Because I'm very, very, very satisfied to be here, to contribute and to get information about the market and about the ETSI.
Okay, thank you. Christian?
So one of the areas that we have found that there are lack of standards to deploy IoT service throughout federated environments. So as you may imagine, there is no single provider that can cover Brazil, right? Or the whole Europe. So there is a need, if you are going to deploy IoT services close to the devices, that there are means that you can federate, that you can share infrastructure, like today in the telecom industry, that you share antennas, cell sites, base stations, and you virtualize everything. The same to address the needs of IoT services from an end-to-end perspective. Device, edge, transport networks, clouds.
So am I correct that this relates to your comment that you made on the lack of an MEC app platform, or to some extent?
That's related. That would be related. So MEC would give a means so that compute infrastructure with MEC allows a developer to deploy its IoT service. But that's not an end-to-end, so to say, service, just the app at some edge. What I mean is that if you are going to provide an IoT service and you need to negotiate with multiple providers so that you can put the compute infrastructure in place, that there are needs for multi-domain type of APIs, federation mechanisms, marketplaces, name it, like you want, and this is something that we have faced in some EU-Brazil projects.
Thank you. I think you wanted to have a reaction?
Yeah. Thank you. It's okay. Yeah, just to jump on what you just said, just to inform you that at the moment in Release 4, 1M2M is working on edge computing. So there is some documentation, very interesting. We are working closely with MEC. So the good thing to be ETSI members is the company are involved in different activities, and we have companies that are involved in ETSI, MEC, and 1M2M, so they make the link. So we have a joint document to outcome in Release 4, addressing the edge computing, fog and edge computing. So I think it could be interesting that we talk about this.
I would like to add that the standardization for us is a must. It's not optional. Anatel is taking care of the connectivity part as well. But the another layers, we have some work to do here in Brazil to achieve a higher grade of the interoperability and all these layers. And is this?
Thank you. Indeed, it is very, I think it's critical to keep that standards aspect in considerations in order to implement, for example, the national plan on IoT or any kind of public policy, and this applies, I mean, equally in Brazil, in Europe, and to keep that in the picture, I would say, for a sustainable, future-proof rollout and keeping the market open, I would say. I mean, both for local industry, but also even foreign industry. It's a matter of I think standards will provide also fairness in or a fair playing field, I would say, between the various industry players. And it is very important, especially for the smaller players or the emerging players, like especially when a region or a country has a lively, let's say, a group of startups, SMEs, typically this is where the benefits are observed, because it keeps the barriers to entry low, and otherwise it's sometimes very clearly impossible to enter the game if you're not backed up with a big, either big money or a big name. So, and usually it's a synonym. And I was wondering if there are ideas that you have in mind to basically kickstart that collaboration on ICT standardization between Brazil and Europe. Are there concrete elements that you have in mind, or specific use cases and requirements, for example, that you would have identified are not covered in international standardization at the moment? How is there is a way to team up in order to cover those aspects? 1 and 2M is a global effort, but it is only relevant if it covers the use cases of the users. So it is also something where inputs are needed. And I'm wondering what are your views basically on how to address that from a kind of practical standpoint?
Well, the standardization as a product like IEC, ISO, and we are, I see that we are a little bit far from these standardization bodies. We are so close with ITU. Right now we have a CBC 3 that we are working together with Anatel and MCTIC to put some recommendations there, but we need to work in this direction to give some users case, and to contribute with the needs from Brazil in another areas, specifically with the industry and another all bodies here in Brazil that are working in IoT.
So I'm a relatively newcomer to the standardization of these issues. We have historically worked on wireless sensor networks, the sensors themselves, and other not off-the-shelf applications. And Sergio told me that we have an issue in Brazil with the quality of service for disaster monitoring networks, for example, where we helped the Samadeng implement a network of these devices, and we could not ensure the timely demand for communication, for instance, across the country, right? And on the other hand, we have our interests in innovation really at the ground level, and I haven't studied the issue, so maybe there's an answer for when our devices or working under stressful conditions. They often work trying to harvest energy from the environment. They may not have that energy to communicate. What are the issues that we can achieve to manipulate the environment such that the relevant data gets across out of a local network? How do we integrate these extreme conditions without altering the standard, right? Looking ahead 25 years of these technologies that are coming up. That's an issue of cooperation that we think we need.
Thank you. Are there any other views in the panel or in the room? Oh, there is.
Hi, this is Adailton from the Dharmatech. I am a security consultant from Dharmatech. I'd like to know about the security of IoT related to laws. For example, we know that in European Union we have the GDPR, General Data and Private Regulation, GDPR, and here we have the LGPD, Lei Geral de Privacidade e Proteção de Dados. So we can know, we can explain about a vision, your vision about IoT relates to data regulation and privacy here in Brazil and European Union.
So the question is to me, I guess?
For a forum who to answer about security, privacy, regulation, and relate to IoT, because we have health, wearable, and we have a mass of data analytics and so on. So we have to control the access authentication. I know that the presenter talk about security, but not relate the laws that interfere in this regulation of data protection in IoT.
Okay, so I try and say something first and let you intervene if you want. So in Europe we have this GDPR, which is now in force. I understand the enforcement of LGPD is coming, I don't know, mid next year or something like this in Brazil. It's not
2020. Next year we have the Lei Geral de Proteção de Dados, Privacidade.
Yes, so it's been adopted, but the entry into force will be next year. Okay. So I think the two frameworks are very close in their spirit, in their provisions, and it is very welcome actually that we have established such frameworks to guarantee privacy and protection of the citizens. That means also that we have to start thinking a bit different when designing the systems that will be involved in the provision of IoT services. And we need to go beyond the traditional security measures and work on specific elements such as anonymization of data when it's possible. There is a whole part of IoT actually which is not dealing with personally identifiable elements, and these are fine. They are basically not covered or not in scope of these laws. But for the rest, I think it really sets or triggers the questioning, I think, for the implementers, if they really need first all of this data, and to triggers the transparency toward the end users, and this is also very important, and ultimately triggers their action in order to make sure that the way they use the data is something that will preserve the privacy using these techniques, for example, to ensure that the data, basically the data elements that are not required, even if initially it comes from a personal or personally identifiable information, then they transform that in the actual, let's say, data element or data part of the data that they will need. And of course it sets some constraints, some constraints on some applications, but it is ultimately for the benefit of the citizens, and for that we are, in the context of ETSI, looking at some of the enhancements that there could be to mechanisms to anonymize data. I mean, you also need basically to adapt the way you process the data and what you want to process.
Now, Anatel is studying in telecommunications sector procedure to verify the procedures used by the operators in telecommunications according to the Lei de Proteção dos Dados. Anatel will audit the procedures, okay, in telecommunication. We are on road in this topic. And the first step was done in 3 months ago, and the procedure that Anatel implemented to block messages and calls from telemarketing. It's the first step, because the messages and calls originated by telemarketing operators is using a personal data, okay? Our numbers, okay? And now Anatel has a procedure to block this call or this message. It's the first step. Next year, we will audit all the telecommunication operators in Brazil. Okay, it's very, very important, very good question.
Okay, Augusto, and then we
Okay, IoT, we have some situation that Anatel is working with the security certification products to IoT, and there was a consultation. I think that we give some suggestions to verify that the security is in the products, it's conforming the standards of security. So it's important the security in the device layer, and also with the GLPD, the security from to all data that was storage.
Okay, one last thing I would add before wrapping up is as a wrap up, is that you just pronounced the word certification, and I think it is also one area where these discussions need to be entertained, I would say, between Brazil and Europe. IoT is going to be clearly in the scope of some security certifications, and Mr. Oliveira was mentioning earlier that there is this what's the name? The economic agreement or partnership agreement between Mercosur and Europe. That means that, I mean, these things, they clearly aim at lowering the barriers to trade, and that means that, for example, in our respective certification approaches, we might want to discuss on which basis we establish the certification, on which standards, for example, are used to evaluate compliance to the specific requirements. If we want to reach a certain level of, not necessarily everything, but a certain level of mutual recognition, for example, then we need to talk about which standards we use, or even think about developing common standards. So I would like to thank you all for your inputs, for your insights, and after lunch, because now it's lunchtime, we are going to have other insights on a bit more practical elements regarding the implementation of IoT solutions in Europe and in Brazil, and also have a very interesting insight on how some of the research areas have contributed to standardization, especially in the domain of semantic interoperability. So I invite you all to come back after lunch and see these further presentations in the afternoon. Thank you.
You can see the map, who is the first time in CPQD, where we are and where is the restaurant. This is the map. It's a 4-kilo restaurant, okay? And there is a cafeteria as well, very close to here. We are going. Yes, at 2 p.m. we will return. We will start. It's going to be more practical cases, okay? Between projects, research and market.